Good afternoon all. Today we are going to see satellite communication. Okay, so I am Dr.K.Saravanan, Professor EC P.S.R Engineering College. So before going for satellite communication, from the word satellite what you get a picture is something which revolves around Earth. Yes, of course it is true, but what revolves around what? So anything, any body which revolves around a primary body, it is called satellite. Actually the word satellite is derived from satellite. It is a Latin word which means that a servant revolves around a master. So what is the purpose of revolving around a master? To serve the servant. Okay. Now we go for the satellite communication in its technical view. So as far you know, you have somewhat an basic idea about satellite by seeing some TV channels or other media. But actually satellite communication has a lot of technical insights into it. So if you take a satellite communication as a subject, okay, we have to go for the fundamentals. Communication, you know, exchange of information from one part to the other part of the world or other part of the place, geographical place. Whatever communication takes place in a terrestrial or in the land, we call it as terrestrial communication. So you may name it as microwave communication. You can also name it as radio communication, broadcasting stations. Everything is the purpose of communicating or exchanging the information from one place to other place. So what is the need for a satellite or a person who revolves around the earth? Okay. So actually you know a natural satellite which revolves around our earth is moon. What moon does? It just reflects the light from sun and gives us light at the night. God created moon not to give light by itself. It reflects the light whatever it gets from sun. So it is a natural light emitting or a natural satellite, as I told, which revolves around the earth to give light to us. So same way, technical satellite is nothing but on par with all the terrestrial communication. It helps, it aids the human society to get the light in the terms of our communication, the information. So any two ends, a transmitter and receiver in a terrestrial communication, okay, sends the information and receives the information, vice versa. Okay, there are a lot of hurdles in the terrestrial communication. As I told, terrestrial communication means earth-based communication. You send the information, you receive the information. So when you send or receive information, you all are now almost in third year VTech, you know through any carrier only you send. The carrier may be microwave, the carrier may be any sort of electromagnetic waves, and you know the EM spectrum. So what happens, there are a lot of line of sight constraints are there. Okay, signal fading is there. So go up. Instead of being stick to the terrestrial communication, you send a body, that is what we call it as satellite, in the space. Send the information through the earth station to the space, receive it. What's that I have shown in the diagram. So I am sending information from the ground station to ground station. Instead of communicating between both of them in the terrestrial way, if it is a terrestrial communication, I have shown a straight line from here to here and vice versa. Now I am sending the satellite up. Satellite is just a repeater, in the sense it's just a reflector. It is just a reflector. As I told, like a moon, natural satellite. I am sending that body up, sending this signal to the satellite, then that satellite reflects back to the other ground station. So both of them are communicating with the help of satellite. Why to send the satellite up? Because you overcome all the line of sight constraints and all the other terrestrial disadvantages you are going to overcome. So when using a satellite for a long distance, it just acts as a repeater. An earth station transmits a signal up to the satellite, means that signal link is called uplink. And what are the satellite signals sent to the other part of the earth station is called downlink. So different frequencies are used. As you all already are aware of terrestrial communication, most of the communication carriers are, not most, almost all, the EM spectrum. So you know at which particular frequency range, okay, is used for satellite communication. I think you would have heard it is around some microwave range, it is around some gigahertz range. Okay, as of now, if you remember this, it's sufficient. Then we can go for the other frequency bands like this L band, C band, everything I'll explain. Just you remember, in gigahertz range, the communication takes place. So, as I told, Earth station communicate by sending the signals to the satellite on an uplink. Everything is there. So, the broadcast nature of downlink makes it attractive for TV programs especially. Okay. Now, we'll just slowly move to the application part. So, direct to user services, as I told, TV services, okay, broadcasting nature. One Earth station, satellite sends to different downlinks for different users. So, it is mainly used for direct to home. Next. So, weather forecasting. The other applications in added to TV signals are internet communication. GPS, you are all mostly familiar with this term. Global positioning satellite. Almost 24 satellites will be there used for precisely locating any object in the Earth's location. So, as I told, the frequency allocation is very important, okay, in the AM spectrum, in the gigahertz range. Even though I have mentioned it in megahertz, but in thousands, anyway, it is gigahertz range. So, this frequency, that electromagnetic spectrum, you have a particular frequency which is prominently used for satellite, is internationally monitored by the standardized bodies. Okay, so they have named it as C band, around 3 gigahertz to 5 gigahertz. Okay, so KU, okay, 11 to 14, KA 17 to 27. This C gigahertz is mostly used for TV broadcasting services. There are different types of satellites based on the location. Okay, so I don't want to go very deep to it in the overview class. Just to remember the word LEO, MEO and GEO. LEO means low Earth orbit, MEO means medium Earth orbit, GEO means geosynchronous orbit. Geosynchronous orbit is very important, that the satellite is placed in the space such that it rotates in the speed of the Earth. LEO and MEO are nothing in the name, you can easily understand. LEO means low Earth orbit. So, around some 500 to 1000 kilometer above the space they are placed for some lower application purposes. So, with this in mind, I will go for the other things in this overview class. So, just have a glance over this, especially GEO alone, you should remember around 36,000 kilometer far from Earth, then only it will be rotating in the speed of the Earth. So, a GEO satellite or geosynchronous satellite, when it sees from the Earth, when it is seen from Earth, it looks stationary because it matches the speed. So, anyone can be seeing it in a stationary way. That means always it looks stationed in respect to Earth. So, other things already explained. So, there are number of satellites as of now. It crossed thousands of satellites around the Earth. I will explain the launching thing. See, as I told, 500 to 1000, then 5000 to 15,000. As I told, 36,000 kilometer is the geosynchronous satellite position. Okay, according to the position and according to the nature of the inclination, they are all working. So, I am here to give a introduction about satellite actually. So, I am very interested to tell about the launching mechanism. So, just last. Yeah, the previous. Yes. So, you are all, since I use this video class to tell you an interesting story, you would have seen this kind of object in your childhood, okay, to throw stone. So, this is what happens actually. So, I want to make a realistic illustration of launching and satellite communication, how it starts. So, you all now got a small understanding, okay, why we need an object to be on par from a large distance from Earth to act as a repeater or a reflector. Now, you understood what is the difference between terrestrial communication and satellite communication. Okay, so I am sending a repeater or a reflector above the earth, and I am communicating the same method of terrestrial communication using that reflector. That is what all about satellite. How the satellite went up, that is called launching mechanism. So as I told, satellite communication, everything is based on the secondary body, satellite. The primary body is what? Our earth. So the satellite, after launching, it acts as a repeater, reflects from the first ground station to the other ground station. So it has an important part inside it called transponder, transceiver otherwise. It translates the uplink frequency and sends to the downlink frequency. Usually uplink frequency is placed a bit above in the gigahertz range, that is around 6 gigahertz. Downlink frequency is around 4 gigahertz due to the gravitational issues. So now everything is clear in your picture, what a satellite means and how it sends the signal, how it receives the signal from the one part of Earth station and sends to the other part of the Earth station. But the very interesting mechanism is launching. So you might have heard in the news always telling about PSLV 3, PSLV 4. What is that PSLV? Polar Satellite Launching Vehicle. So in 1990s only such launching vehicles have been introduced in our India. Actually the history of satellite I have not told much because I want to make a clear picture on you what satellite is. Then only have to go for the history, because earlier the main person behind this satellite communication is Kepler. He only told a secondary body which revolves around an ellipse, okay, covers in a equal at an equal period of time, it covers equal area. Like that he has given so many laws. That has been inspired by Clark, who is otherwise called as father of satellite. Okay, in 1945 range, during the World War time, he was working in satellite launching methods. So now the first satellite actually launched was Early Bird, and there was a competition between, as usual, between US and USSR, that is the former Soviet Union. So they told our Sputnik was the first launched satellite. Anyway, both are very early launched satellites in the years 1950s, okay, 57 I think. But could you imagine in which year our Indian satellite was launched? Yes, around 1975. If you want to remember it, 1957, just put the 5 and 7 vice versa, 1975, Aryabhatta. Okay, so these are the satellites launched. So how it is launched? Usually through vehicles. As a bus or a car which carries the passenger, satellite launching vehicles are different. So as I told, my main objective in this first class is to take a clear picture on you. You should not imagine rocket also as a satellite and satellite also a satellite. So now from this class you will easily understand launching vehicle carries a satellite. Satellite is a secondary body which will expand its solar sails and be launched in the space. So the launching vehicle looks like this. Okay, imagine this is the launching vehicle. Okay, this is the satellite, and the satellite, as I told, it is just a reflector. It gets the uplink frequency and gives to the downlink frequency. Uplink and downlink are nothing. The signal from one station to another station, since it goes to satellite and goes to the other station, it is called uplink then downlink. So that is performed by transponder. Here these two sails are called solar sails, because satellite will receive the sun's energy and convert it to the power there, whatever the necessary power are there needed. So solar sails will be there. This is my objective. You would have got a clear-cut idea. Now I will tell few words about this vehicle and close. So launching vehicles, LV. As I told, Indian launching vehicles usually launched from Sriharikota. It is PSLV, okay, Polar Satellite Launching Vehicles. But as you all know, American launching vehicles are called as shuttles. They are all very famous launching vehicles because they will take the satellite, launch it successfully in the space, then come back safely. So they are called as shuttles, reusable. But Indian vehicles are still not to that level. We are all working. So that satellite vehicle is called as expandable satellite launching vehicles, ELVs. Okay, so we have to move to ELV to shuttles. Okay, so such a ELV is called PSLV. Now you would have got a clear understanding. PSLV, and please just refer the latest launched vehicle last year. Okay, PSLV numbers. So almost 40 vehicles, 40 launches have been occurred from 1995 to 2017, I think. Now it has to be updated. So these are the basic fundamentals, and launching vehicle, how it works, I will add and close. So a rocket, imagine, it takes number of satellites, n number of satellites, then using all the propellant and the fuel, it is just launched using a countdown, and it goes to the space. As you all know, there are elliptical orbits and circular orbits. Okay, from Earth, any orbit a satellite can revolve around. Okay, usually geostationary orbits are circular orbit. So imagine circular orbit. Okay, so this we call this perigee and apogee. We will see in the later class. So when a satellite to move to such circular orbit, it has to take number of temporary elliptical orbits. Okay, there will be motor kicks will be there, apogee kick and perigee kick we will call. That we will later see. Using that it will shift, and at a point of time it reaches the geostationary orbit. Mostly geostationary is very highly applicable satellite. Okay, so the launching vehicle mechanism, this is a small picture about it. Temporarily it shifts number of orbits and reaches the desired orbit. So the launching vehicle, which is called rocket, okay, it takes the satellite and launches successfully in the space. This is all about the basics of a repeater or a transponder or an object, secondary object, which continuously revolves around our earth and gives coverage for all the applications I have listed, like navigational, meteorological applications, geographical applications, for weather forecast, direct to home, that is D2H. So n number of applications are there. Even education purpose, we have lot of satellite, Intelsat, EduSat. Okay, and now our 75th what we call the Independence Day is celebrated with launch of 75 satellites. Okay, so that is the mission now our present Indian government has taken. So you can also, if you are very much interested, start preparing a small satellite and try to launch it with the mentor. Okay friends, so now you have a clear understanding about what satellite is, how it is launched to the space using launching vehicle, and overall view. As I told, satellite is a secondary body which is launched in space, used to connect two earth stations instead of terrestrial communication. So what are the launching vehicles we have seen, especially PSLV, and I told now the Indian government is taken a step to launch around 75 satellites from the student side also. So if you are interested, you can also be a part of it. See the 75satellites.com website and be knowledged. Thank you very much for listening this lecture, and I think this lecture would have been facilitated for you to be an introductory lecture to learn satellite communication. Thank you.